Hello there, welcome to the June 2018 applied paper. Here we're looking at question 9. Two small balls, P and Q, have masses 2m and km respectively, where k is less than 2. The balls are attached to the ends of strings that pass over a fixed pulley. The system is held at rest with the string taut and the hanging parts of the string vertical, as shown in figure 1. The system is released from rest and, in the subsequent motion, P moves downwards with an acceleration of magnitude 5g/7. The balls are modelled as particles moving freely, the string is modelled as being light and inextensive, the pulley is modelled as being small and smooth. Using the model, find in terms of m and g the tension in the string. Okay, so let's look at particle P here. Particle P, it says here, is accelerating downwards with a magnitude of 5g/7. So the way we'll do that on our diagram is with a double arrow, acceleration 5g/7. Now we need to think about what forces we have acting upon P. We have the weight force, that would be 2mg, that's just mass times gravity. And then upwards will be some tension in the string. So let's set up for particle P an F equals ma formula. So this is going to be the total forces. Now because we're going downwards, because the particle is accelerating downwards, we're going to set downwards to be positive in this question. So downwards by 2mg, so that's going to be positive. Upwards by t, so that's going to be included as a minus t. And then this will equal, those are the only two forces, so this will equal mass times acceleration. The mass of this particle is 2m, and the acceleration is 5g/7. So therefore, let's move things onto the other side. It's going to be 2mg minus 10mg/7, when you simplify that, equals t. So that's going to be 14/7 minus 10/7, so that would be 4mg/7 equals t. So hopefully that's made sense there. So we set downwards to be positive on this particle here. We have 2mg as the weight force, that's always mass times gravity. Upwards is tension, and then we have equals m times a. Moving on to part B, explain why the acceleration of Q also has magnitude 5g/7. Well, the reason for this is because the string is taut. I'm just going to read this out actually. Because the string is taut and inextensible, therefore acceleration throughout the whole system will be equal. Because the string is tight or taut, as soon as P moves, and whatever acceleration P has, Q is going to have the same acceleration. Moving on to part C now. So for C, this is going to have an upwards acceleration of 5g/7 as well, with a weight of kmg, with a total tension value of T. Now the tension value is going to be exactly the same as the tension value here, 4mg/7. So T equals 4mg/7. So part C is find the value for K. So what I'm now going to do on particle Q, I'm going to do an F equals ma formula. Setting upwards to be positive here, because G is going to be travelling upwards. If P comes down, Q goes up. So it's going to be T, which is 4mg/7, that's T. T goes upwards. Kmg comes downwards. Equals mass times acceleration. So Km times acceleration, 5g/7. Okay, so let's now start moving stuff onto the side. In fact, the first thing I'll do is I'll cancel out the m's and the g's from all of this. So let's simplify this to 4/7 minus k equals 5k/7. Let's now add the k onto the other side. So it's going to be 4/7 equals, so that'll be 712k/7. And then let's times by 7 on both sides and divide by 12. So k is going to equal 1/3, or 4/12. So there we are, that's the answer for part C. Moving on to part D, identify one limitation of the model that would affect the accuracy of your answer to part C. Well, friction on the pulley system, maybe. Maybe there's some mass in the string, or the mass of the pulley system. Maybe any of your potential answers there. It's just a 1 marker for part D, so maybe you might want to mention there might be friction on the pulley system, or maybe you might want to mention there's maybe a mass of the string that we have to take into account. Or maybe you might want to mention the mass of the pulley system, or anything else that may affect the question here. Maybe there might be air resistance that the particles are facing. So there we are, that's the answer for question 9, worth 9 marks in total there. And that's the answers for for paper June 2018 for the applied paper. Best of luck with your 2018, for your 2019 exam. And if we've already got the papers out, maybe you'll have a go at the applied paper for June 2019. Thanks very much.